So in the last class, if you can see the different operations actually happens due to change in temperature and pH. And we have also mentioned that if you have means if you raise the temperature in your saccharification operation also at a faster rate, you will end up by getting a lot of non-fermentable sugars. If you raise the temperature at a slower pace, then you will get fermentable sugar. Similarly, in case of fermentation, you can have buttery flavor because of this formation of diacetyl from alpha acetoacetic acid, acetolactic acid. Now, in fermentation, we actually try to have significant amount of yeast present in the system to reduce the lag period. But in primary fermentation, mostly the yeast will consume oxygen and produce carbon dioxide, and it will also consume all the oxygen and ultimately make that system anaerobic, and then you will have further secondary fermentation. So for primary fermentation, it may take 4 to 5 days, and then you have to wait for another few days for secondary fermentation, and at the end of 10 to 12 days, you will actually get complete utilization of fermentable sugar, and then you can get reasonable amount of alcohol in the broth, and then subsequently process it to get your final beer. Now, when you do this fermentation operation, at the initial stage, you will have formation of carbon dioxide and the residual higher molecular weight protein, and also some lyse yeast cell will create foams on the top, and then due course of time that foam will try to settle down. Now, if you have if you don't spend substantial amount of time for fermentation, then you will end up by getting a lot of residual sugars, and also the top layer will also have issue with formation of top foamy layer. And similarly, if you spend too much of time in the fermenter, then you will end up by getting slurry of yeast, and that yeast will also try to autolyze, and they will actually change the flavor of the beer. So you don't keep it for too short or too long period to avoid getting clarity as well as taste of the beer. Now, mostly we use that Saccharomyces uverum, which we have mentioned earlier about this particular strain. Saccharomyces uverum is mostly used for production of beer. So, sorry, it is RUM. So mostly when you add adjunct, then you will compensate for carbon sources, and the presence of adjunct will actually give you substantial amount of glucose source, and due course of time the entire glucose should get fermented, and you should get reasonable amount of ethanol. But only problem is when you have high concentration of glucose at the initial stage, then your fermentation will get inhibited, because this sucrose is hydrolyzed by invertase. Now this hydrolysis process is actually exogenous. So when you have this hydrolysis, then you will get invertase. Similarly, maltose will get transported to the cell by the cell permease system. So in that case, if you get substantial amount of glucose in the system, then you will have issue for this transport. So maltose will get hydrolyzed by maltase. So when you have maltose sucrose, so sucrose will get hydrolyzed by invertase, maltose will get hydrolyzed by maltase, and you will get glucose. But this transportation of maltose into the cell is actually done by a permease system. And if you have high concentration of glucose, that activation of permease system will get inhibited. So essentially, you can say transportation of glucose within the cell will get inhibited if you have high concentration of glucose in the system. So at the initial stage also, you don't want very high concentration of glucose, because very high concentration of glucose will actually inhibit or show substrate inhibition to this particular yeast. And even in the last class also we have mentioned about this aldehyde, because aldehyde formation is also possible, but you have to maintain their concentration as minimum as possible, because for your EMP pathway, for alcohol, aldehydes are precursors. So you will have some amount of aldehyde, but you need to maintain the concentration at within a lower limit, like within 10 ppm. And when you have hydrogen sulfide formation, you need to make sure that substantial amount of carbon dioxide is passed to the system, which will expel the hydrogen sulfide, and that will also not have any further negative effect in the drink or in the final broth. Now, when you try to get the final fermented broth, you actually have three different objectives. So one is maturation of flavor. So after getting the final broth, you have three major objectives. One is maturation of flavor. So this broth, you already got the broth from the fermenter. Now you have three different objectives. One is maturation of flavor. Second is physical stability. So that means you need to so flavor maturation, physical stability, and clarification. So you might have seen in many beers, they will have different kind of turbidity. So if you have too much of uh, insoluble proteins or too much of higher molecular protein, you will get turbid beer. And also if you get some residual yeast, very small amount of yeast, then also it can create some turbidity. Similarly, when you talk about physical stabilization, there it also depends on the constituent. So if you have substantial amount of protein as well as carbohydrate present in the system, and still you have some amount of yeast, that means you still have, if you just keep it for a little bit longer period of time, or if you just prolong the secondary fermentation, the residual sugar will get fermented and produce ethanol. So physical stability you can attain at different stage of maturation. Now maturation with respect to carbon utilization, maturation with respect to flavor. So flavor can get created by different agents. So hop is uh, actually adding flavor to the system, or the different oils or um, aldehyde are actually creating or imparting certain flavor to the system. So again, when you have longer aging of the beer, then due to fermentation or prolonged fermentation, you will have conversion of, even in the last class also I mentioned about conversion of diacetyl to butanediol or acetone, which will get assimilated inside the cell of the yeast. So when you have longer period of operation, maturation of color, maturation of flavor, physical stability, you will attain. And if you take beer at different stages of maturation, like if you suppose you have a provision to go for continue the secondary fermentation at low temperature. Obviously, when you try to store them, you will maintain them at low temperature. So initially, you are doing the fermentation at optimal condition. So now, after completing the fermentation in the fermenter, you packed it in a specific barrel, and there you can just wait for aging. So till this stage, it has actually happened in the optimal temperature. Say even if you do it say at 30 degrees centigrade. Now this period when you keep it in the barrel, there you are actually maintaining less than 10 degrees centigrade. So obviously the rate of fermentation will get slow down because you are maintaining lower temperature. But if you withdraw any liquid or any beer at this point, you will get a different composition. If you withdraw at little longer period, after longer period, you will get a different composition, and withdraw after say 2 years, you will get a different composition. So maturation or aging will have significant impact on flavor maturation, color maturation, and also stabilization. So it will also have impact on the clarification, because at different level you will get different type of beer. So if you prolong this storage and allow it for complete fermentation, you will get almost clear beer. Whereas if you withdraw it before complete maturation, then you can get little bit of haziness. So mostly this maturation is done in a closed vessel, and there you have option for CO2 adjustment. So one option is whenever it will ferment, it will actually produce ethanol, carbon dioxide. So whenever you will have carbon dioxide production from the fermentation, obviously during storage condition, the rate of fermentation is very low. So formation of carbon dioxide is also very low. But deliberately, if you want to add extra carbon dioxide, then that also you can do by externally adding carbon dioxide to the vessel, which will adjust the carbon dioxide content based on your preference. So different beer manufacturing industry, sometimes they will try to have fizzy drink, so they will try to have pressurized carbon dioxide. Sometimes they will try to have and when you vary this carbon dioxide concentration, obviously pH of the system will also change, and accordingly taste will also change. So you can adjust the carbon dioxide content depending upon your preference. And here in this particular process, when you do this aging, so this process is actually known as this, all these different activities actually happen during aging of or lagering, or you can say finishing of beer. So all these processes will actually happen when you try to go for the maturation of the beer or finishing of the beer. So you can have or you can call it as lagering process or aging process. And this process can be of say 2 to 6 weeks. And in some cases, you can actually go up to a little bit longer period, even 1 year. That depends on the storage. So when you talk about long-term storage, yeah.
Sir, I don't know why I am not able to see the blackboard. See the whiteboard. I don't know about others.
I think whiteboard is visible to us. Ratnesh, you can like rejoin.
Okay.
Yes, sir, it is visible to us.
Acha. Okay, then Ratnesh has to rejoin. Yes. Ratnesh, can you see the screen now?
Sir, not yet. I rejoined, but I am not able to see. Perhaps something is wrong with my internet connectivity, I guess.
Able to see the screen. I guess it's problem with Ratnesh's system.
Okay.
Yes, sir. Yes.
Okay. Okay. So for finishing, maybe Ratnesh.
Yes, sir. Now I can see.
Okay. Okay. Thanks. So during this lagering process, as I told you, means you can go up to 2 to 6 weeks, and sometimes you can actually prolong this aging process. But only thing is, when you do it for 2 to 6 weeks, you may maintain the temperature in the range of 3 to 6 degrees centigrade. But if you want to go for longer period, like if you go for say 1 year, then substantially you will reduce, slowly you will reduce the temperature to even -1 degree centigrade. So for long-term storage, you go for -1 degree centigrade, and here you still have substantial amount of yeast. Means you will have almost 1 million yeast cell per milliliter. So in the final process, wherever you are actually storing them in a barrel, there in barrel also you have 1 million yeast per milliliter, and that you keep it for almost 1 year, and you maintain at -1 degree centigrade. So slowly this yeast will actually try to utilize the fermentable sugars, and also different metabolic activity will happen in presence of all other constituents, like the residues you get from hops, or different other mineral oil you get from adjunct. So everything will actually react, and slowly it will change the taste and flavor, and that may take little longer period of time. So after 1 year, what you do, you just take this liquid out from the barrel and then do a simple filter. So you just use a simple filter. So you can have plate and frame filter unit, and after filtration you just get the clear drink from the filter. Now one important thing is carbon dioxide adjustment. So different industry, they use carbon dioxide for different purposes. Sometimes they try to have carbon dioxide saturated beer. So if you want to have this carbon dioxide saturation, you have one natural process, because naturally in the fermenter also carbon dioxide will produce during primary as well as secondary fermentation. And you can create pressure. That means in the covered fermenter, instead of opening the gas vent, you can create pressure by just closing the gas vent. So if you have fermenter which is closed, now in the fermenter on the top you have some vent for releasing the gas pressure or releasing the gas. So deliberately you can just close this valve, so gas will get accumulated inside. Gas means mostly carbon dioxide, so that will get accumulated inside, and it will increase the carbon dioxide pressure. So natural way you can actually increase the carbon dioxide content, or you can saturate the liquid with carbon dioxide. Only problem with this is if you have some undesired gases. Suppose you are getting some formation of H2S or other volatile organic components which are creating a different kind of smell or different kind of taste, then this process may not be very lucrative. So in that case, you have to actually flush the liquid or flush the entire broth with external carbon dioxide to remove all undesired gases. So this particular natural saturation is only possible if you are sure that you are not getting any other undesired gases. And also, even if you get undesired gases, the concentration would be very, very minimal, so you can neglect them, or that this small concentration should not impact the quality of the beer. Then only you can go for this natural saturation. Now, second option is you can just purge externally. You can purge carbon dioxide to the system and then saturate. Third option is whatever beer you get. So both the options, natural as well as purging externally, that is happening inside the fermenter. Now third option is if you want to have increase in concentration of carbon dioxide in the final beer, then in the process line you can purge the carbon dioxide. So in the process line means after beer, whatever you're getting in the bottling plant also, you can just add substantial amount of carbon dioxide, and that carbon dioxide you need to generate from any other sources. You can actually collect the carbon dioxide from the fermenter. So whatever gas you will get from the fermenter, that you can process through a scrubber to get rid of other contaminants, and then the carbon dioxide you get from the system can be used for increasing the carbon dioxide concentration in the final drink. Is it clear to everybody?
Yes, sir.
Okay, okay. Now, when you talk about flavor maturation, because I have mentioned in this aging process, one of the primary goal is to get the flavor matured. So during flavor maturation, you have to make sure that you are not having any hydrogen sulfide, because different component which can impart flavor or a different kind of taste, that those component you need to remove from the system. So we have already mentioned about diacetyl. Similarly, hydrogen sulfide. Then you have proteinaceous component. So there is a possibility of, like, when you have a lot of proteinaceous component having sulfur moiety, you can have formation of mercaptans. Like in the LPG gas, we have methyl mercaptans. So similarly, in the system also, and the smell you get in LPG gas because of mercaptans. So the similar kind of mercaptans can also form. During degradation of proteins, and the sulfur moiety will actually create this mercaptans. So removal of, say, diacetyl or mercaptans is actually a volatile component. So you can have, if you sparge carbon dioxide, then you can get rid of H2S and mercaptans. But diacetyl removal is depending on the yeast concentration, because you have mentioned earlier also. So diacetyl can get accumulated inside yeast cell at high temperature and low pH as acetone or butanediol. So it is dependent on the yeast cell concentration, and also it depends on the temperature and pH you are maintaining in the system. So if you really have problem with diacetyl, then you have to maintain a little bit higher pH and higher temperature and low pH, and the yeast will actually assimilate it, and it will get you can get the diacetyl free liquid then. And for mercaptans and hydrogen sulfide, similarly dimethyl sulfide, these are all volatile components. Mercaptans in dimethyl sulfide. So this component can be removed by purging carbon dioxide. So if you just purge carbon dioxide, it will actually remove or expel the other VOCs and H2S from the system, so you can get a different kind of flavor. So flavor maturation can be done by with the help of yeast or by sparging carbon dioxide. Now, when you talk about stability, because I have also mentioned about this clarification or physical stabilization particularly. So when you talk about physical stabilization, there we try to see the stability in terms of microbiological, physical and foam, because microbiological means the yeast cell you have in the system, whether you should have substantial amount of yeast cell which can actually go for autolysis and then change the taste or deteriorate the quality of beer. Similarly, the color, flavor, they are part of the physical stability, and also foam formation. So if you have a lot of protein molecules and substantial amount of carbon dioxide formation and the cell lysis can lead to formation of micelle, and then you will end up by getting a lot of foams. So whether you try to have a certain amount of foam in the beer, because few customers they prefer foamy beer. So if you really want to maintain a certain level of foam, then you actually allow the organism to have certain concentration, and also you allow to have certain amount of protein present in the system, so you get desired amount of foam. So when you talk about microbiological stability, that you can obtain by pasteurization, because in earlier case also you have mentioned you can raise the temperature to 80 degrees centigrade or 82 degrees centigrade to get stabilized beer. So it will stabilize the beer. Another option is if you don't want to go for elevation of temperature, because obviously when you try to elevate the temperature, you will be losing certain amount of ethanol also. So in such cases, you can do simple filtration, sterile filtration. So you can choose membrane or filter membrane which will have a very low pore size. So essentially the pore size should be in the range of 0.45 micron to 0.8 micron to get rid of the yeast cell present in the system. So mostly this particular filtration process is used for production of draft beer. Now, depending upon your filter use, you actually get different fractions, because obviously the yeast cell, different sizes of each cell will be there based on their age, cell age. So if you use little bit higher pore size, say 0.1 to 2 micron, or maybe 1 to 10 micron, you will get different pore size of filter membrane, and based on that you will actually get different size cutoff. So certain portion of yeast will get separated, still you will have certain amount of yeast present in the system, and that will create turbidity or haziness in the liquid. So the polypeptide and polyphenols, they are also responsible for creating this haziness. So if you have polypeptide and polyphenol and you maintain the beer temperature relatively higher, like more than 20 degree or around 30 degrees centigrade, you can still get some haziness because of the protein precipitation. And if you really want to reduce the haziness, then you can use different enzyme to just catalyze this polypeptide. So if you just use say papain, that will catalyze or hydrolyze some polypeptides. So then it will reduce the color intensity, or maybe it will reduce the haziness. And you can use different adsorbent. So I have mentioned about filtration to remove yeast cell, and there actually you have option to choose say 0.545 to 0.8, 0.1 to 2 micron. Similarly, you can have 1 to 10 micron. So depending on the filter size, you get different kind of clarity in the liquid. Similarly, the polypeptide you have, that can be removed. So at different temperature, you get the precipitation of polypeptides. Now, or if you really want to remove them, then you can use different enzymes. So one of the common enzyme is papain. So only problem is when you use these enzymes, you have to make sure that the process is done in such a way that this enzyme can also be removed after doing this enzymatic treatment. So this enzyme should not impart any other foreign taste to the drink. So here you can have, and then so one is precipitation. So you can have precipitation. So it is actually this, when you use enzyme, that is actually your hydrolysis. Another is separation due to precipitation. And third option is, so you elevated temperature, or you can add certain salt that can precipitate. And third is you can have adsorption. So mostly silica gel. Silica gel is used for adsorption. So polypeptide can be separated, and obviously if you have separation of polypeptide, you will get different level of haziness or different level of turbidity in the system. And if you have a lot of polyphenols, mostly obtained from these hops and other ingredients, polyphenols, then also you can use some other type of adsorbent. So instead of silica gel, maybe you'll be using, say, nylon is also a good adsorbent for polyphenols, or maybe you can use polyvinyl, polypropylene. So nylon is one of the common. Nylon 66 is actually one of the common adsorbent for removal of polyphenols. So if you remove this, then obviously you will get little bit of clarity in the beer. And the foam stabilization is also possible because you have seen that alpha acids obtained from hops, they are also responsible for formation of foam. So all this adsorbent, they can also absorb certain amount of foam, and you can get a desired foam in that final drink. So foam stability can also be done by this adsorbent. So the last stage for this maturation is your clarification. So when you try to clarify this beer, that means you have to make sure that the beer should not have any further yeast cell, because even for prolonged aging or lagering, even if you have 1 million cells per ml, that should not be there in the final drink. So you just use either centrifugal separation or your plate and film filter to separate the cell biomasses. And in some specialized cases, people may also use wood pulp or your cotton fiber, because wood pulp and cotton fiber can actually give a little bit of flavor and taste to the final drink. And while doing this filtration, suppose you are doing it in a rotary vacuum filter, where, or maybe in the plate and film filter, you add some amount of filter rate, because yeast cell inherently is very sticky. So the cake, whatever will form on the surface of the filter system, will be very compressible. So to just add little bit of incompressibility, you add small amount of filter rate, so you will get substantial amount of filtration, or you get prolonged filtration without getting too much of pressure drop. Because if you don't use any filter rate, you'll end up by getting a lot of pressure drop, which will not allow you to run the system for longer period. So typically you get almost say in 100 barrel processing, when you try to produce 100 barrel of beer using this filter system, you typically add 25 to 40 pound of filter rate. And packaging is actually done in different ways. You can have can or you can have bottle. And as I mentioned earlier, if you need to have a little bit of saturation with carbon dioxide, so during packaging also, you saturate with the carbon dioxide. Or if you don't want to have any saturation, then you just pack it without adding any extra carbon dioxide. So most of the cases, beer is actually sold either in bottle or in can. And when you pack them in a bottle or in a can, you can have a shelf life of say 1 to 2 years. Generally, people don't prefer to use it beyond the prescribed shelf life. So if you have more mature beer, you can store it for longer period. If you have less mature beer, it will have a shorter shelf life, because maturity means you are trying to remove all fermentable sugars and other molecules which can interact with yeast. So you try to ensure that there is no further fermentation happening in the system. That's why you can store them for longer period. So this is all about your beer production. So in the next class, we'll discuss about wine manufacturing. Anybody has any question? One interesting thing is different country, they use different kind of model to have a stable supply chain of this can or bottle. So suppose you are using can, and if you just return it to the specific vendor, then you can actually get some incentive. Similarly, if you return the bottle, you get some specific incentive. The intention is actually to recycle the can and bottle to the system, so to minimize the wastage. And obviously, before bottling them, this can as well as bottle both are actually sterilized, or both are actually kept at a relatively high temperature, like pasteurization temperature, to ensure there is no contaminant present in the can. So before bottling, they make sure that the can as well as bottles are actually contamination free. Okay, then anybody has any question?
Okay, sir, I do not have a question. Maybe other people have. I could not like see in the beginning, and also I joined a bit late, so I was not able to understand everything. I will maybe rewatch the video after that.
Okay, sure.
Thank
Yes.
you, sir. Thank you.
Okay. Thank you. So if you don't have any other question, then I'll just stop here. So in the next class, we'll start discussing about wine manufacturing process.
Yes, sir. Thank you, sir.
So thanks.
Thank you, sir.
Thank you, sir.
Thanks. So we'll meet again on Tuesday. Have a nice weekend.